The Thermoplastic Composites Application Centre in the Netherlands, part of Saxion University of Applied Sciences, is an independent innovation, research and development centre that aims at making thermoplastic composites work for industry. Companies wanting to innovate with thermoplastic composites can contact TPAC for access to expertise and manufacturing facilities, such as Stellantis, a leading global car manufacturer and provider of innovative mobility solutions. The company is interested in new technological solutions based on 3D printing to produce automotive parts. Stellantis approached TPAC regarding their knowledge of thermoplastic composites and recycling.
For Stellantis, we investigate how we can use 3D printing technology to manufacture automotive parts. Especially 3D printing of composites is a new and promising technology. It allows us to make lightweight composite structures where we can save tooling costs and assembly costs. Here we work in close cooperation with our partner SEAT.
SEAT is a technology supplier of 3D printing equipment on the frontier of large-scale composite additive manufacturing. On Stellantis' request, SEAT printed stiffening ribs on composites parts supplied by TPAC. The SEAT system uses fibre-reinforced thermoplastic pellet extrusion, utilising industrial robots to guide print heads along a pre-programmed toolpath while extruding thermoplastic material. This results in the creation of a 3D model layer by layer. A new non-planar toolpath strategy had to be developed to enable the extruder to accurately follow the shape of the composite panel. Additionally, to ensure a strong interface bond between the reinforcement rib and the composite panel, an additional heat source was used to heat the area in front of the nozzle on the panel. After the 3D prints have finished, the parts go to the TPAC facilities for mechanical testing. In addition, at the TPAC facility, another 3D printing technique is available. Here, an in-house developed printing head is used to print fibre-reinforced composite tape together with additional polymer, resulting in a continuous fibre-reinforced part. After the prints are finalised, they are tested to determine their mechanical properties. In TPAC's lab, a variety of tests are available. In this case, 3-point bending tests were done to determine the flexural behaviour of the printed parts.
Our lab and production facilities are equipped to conduct research for our partners. We typically form a bridge between science and practice in order to develop applications. Composites were originally used in aerospace and Formula 1, but here we make composites affordable and accessible for the small and medium enterprises in many different markets.
The project has shown the possibilities of 3D printing for producing a typical automotive part without the need for costly new tooling, allowing for a faster part development and production process. Visit thermoplasticcomposites.nl for more information.